There is a single rock floating in space right now that is worth more than the entire global economy. $30 quintillion. That's a 3 followed by 19 zeros. And whoever figures out how to mine it first won't just become a billionaire. They'll become the world's first trillionaire. Right now, as you're watching this, there are people planning the biggest gold rush in human history. Except they're not looking on Earth. They're looking up, way up. In the asteroid belt between Mars and Jupiter, there are chunks of rock loaded with more gold, platinum, and rare metals than we've mined in all of human history combined. We're already talking about asteroids that contain trillions of dollars worth of resources just floating around in space waiting to be claimed. Companies like SpaceX, Blue Origin, and specialized asteroid mining startups are racing to figure out how to grab these cosmic treasures. And the winner of this race won't just get rich. They'll fundamentally change the global economy forever. In this video, you're about to discover why asteroid mining is the next trillion-dollar industry, which specific asteroids are worth the most money, who's actually working on this right now, and why the person who cracks this code first will make Jeff Bezos and Elon Musk look broke. The space race is back. But this time, it's not about exploration. It's about money. Lots and lots of money. Let me paint you a picture. Imagine you're standing in your backyard and you find a rock. You pick it up and realize it's not just any rock. It's solid platinum, the entire thing. A rock the size of a football made of pure platinum would be worth over $10 million. Now imagine a rock the size of a city made of platinum. That's essentially what some asteroids are. Floating mountains of precious metals just drifting through space. This isn't science fiction. This is real. NASA has identified thousands of asteroids that contain massive amounts of valuable materials. One asteroid called 16 Psyche is believed to be almost entirely made of metal. Scientists estimate it contains iron, nickel, and precious metals worth over 10,000 quadrillion dollars. That's more money than currently exists on Earth. The entire global economy is worth around $100 trillion. This single asteroid is worth 100,000 times that amount. Let that sink in for a second. One rock in space is worth more than every stock market, every piece of real estate, every company, every currency, and every asset on Earth combined. And there are thousands of these asteroids out there. We're not talking about getting rich. We're talking about wealth beyond human comprehension. But here's where it gets really interesting. The reason these asteroids are so valuable isn't just because they contain precious metals. It's because of how rare these metals are on Earth and how desperately we need them. Take platinum, for example. Platinum is used in everything from catalytic converters in cars to medical equipment to electronics. It's essential for modern technology. But platinum is incredibly rare on Earth. We mine about 200 tons of platinum per year, globally. That's it. And most of it comes from just two countries, South Africa and Russia. This creates supply problems and keeps prices extremely high. Now imagine if someone could access an asteroid with 1 million tons of platinum. They wouldn't just be rich. They'd control a resource that every tech company, car manufacturer, and electronics maker on Earth needs. They'd have a monopoly on one of the most important materials in modern industry. That's not just wealth, that's power. The same goes for other metals. Gold, obviously, is valuable. But asteroids also contain massive amounts of rare earth elements. These are materials with names most people have never heard of. Neodymium, europium, terbium, dysprosium. These elements are absolutely critical for making smartphones, electric vehicles, wind turbines, and advanced electronics. China currently controls 90% of the global supply of rare earth elements. They've used this control as political leverage multiple times. Any country or company that could access rare earth elements from asteroids would break China's monopoly and gain enormous strategic advantage. But before we get ahead of ourselves, let's address the obvious question. If asteroids are so valuable, why hasn't anyone mined them yet? The answer is simple. It's really hard. Space is far away. Asteroids are moving. Getting to them requires massive amounts of fuel and money. And once you get there, you need to figure out how to mine rock in zero gravity, process it, and bring it back to Earth. Every step of this process is incredibly difficult and expensive. Let's break down the challenges. First, you need to identify which asteroids are worth targeting. Not all asteroids are created equal. Some are mostly rock and ice. Others are metal-rich. Scientists classify asteroids into different types. C-type asteroids are carbonaceous and contain a lot of water and organic compounds. S-type asteroids are silicate-based and contain some metals. M-type asteroids are metallic, and these are the jackpot. These contain high concentrations of iron, nickel, and precious metals. The problem is we don't know the exact composition of most asteroids. We can make educated guesses based on how they reflect light and other observations, but we won't know for sure until we actually visit them and analyze them up close. That means spending millions of dollars to send a probe to an asteroid just to figure out if it is worth mining. That's a huge financial risk. Let's say you identify a promising asteroid. Now you need to get there. The closest asteroids to Earth are called near-Earth asteroids, or NEA letters. There are over 30,000 known NEA letters. Some of them pass relatively close to Earth by space standards. Anyway, we're still talking about millions of miles. Getting to one requires a spacecraft with enough fuel to make the journey. This isn't like driving to the grocery store. Space travel requires precise calculations. You can't just point a rocket at an asteroid and go. You need to calculate orbits, launch windows, and trajectories. Miss your launch window, and you might have to wait years for another opportunity. Once you reach the asteroid, you need to land on it. Except landing is the wrong word because asteroids don't have much gravity. The asteroid Bennu, which NASA's OSIRIS-REx mission visited, has gravity so weak that if you jump on its surface, you'd float away into space. So instead of landing, spacecraft need to carefully match the asteroid's rotation and gently attach themselves. This requires incredibly precise control and sophisticated technology. Now comes the actual mining part. On Earth, mining involves digging, drilling, and blasting rock. But in space, there's no gravity to hold things down. You can't just use a shovel. When you try to dig, you'll push yourself away from the asteroid instead of digging into it. Every action has an equal and opposite reaction, and in zero gravity with no friction, that reaction sends you flying. Engineers are developing various solutions to this problem. Some ideas include using nets to capture material. Others involve heating the asteroid's surface to release metals. Some proposals suggest bagging the entire asteroid and bringing it closer to Earth or the Moon for processing. But let's say you figure out how to extract material from an asteroid. Now you need to process it. Raw asteroid material isn't immediately useful. You need to separate the valuable metals from the rock. On Earth, we have giant refineries and smelters to do this. In space, you need to build similar facilities. Some plans involve processing material right there on the asteroid. Others suggest bringing raw material back to Earth or to a space station for processing. Each approach has massive technical and financial challenges. And then there's the biggest challenge of all, getting the material back to Earth. This is where the economics get tricky. Launching things into space is incredibly expensive. Right now, it costs roughly $2,000 per kilogram to launch something into orbit using SpaceX's Falcon 9 rocket. That's already the cheapest it's ever been. But even at that price, bringing back tons of material from an asteroid would cost billions. The math needs to work out. The value of the materials you're bringing back needs to exceed the cost of the mission. Otherwise, you're losing money. Here's where things get interesting though. The cost of space travel is dropping rapidly. 20 years ago, it cost over $10,000 per kilogram to reach orbit. SpaceX has brought that down by 80%. And they're not done. The Starship rocket that SpaceX is developing aims to reduce costs to under $100 per kilogram. If they succeed, the economics of asteroid mining suddenly become viable. At $100 per kilogram, Bringing back platinum worth $50,000 per kilogram makes perfect sense. Elon Musk has said publicly that his main goal with SpaceX isn't just to explore space, it's to make humanity a multi-planetary species. But he's also said that asteroid mining will be a natural outcome of cheaper space travel. Once the cost drops enough, mining asteroids becomes inevitable. Someone will do it, and whoever does it first will have a massive advantage. This is why multiple companies and governments are investing heavily in asteroid mining technology. Let's talk about who's actually working on this. The first serious asteroid mining company was called Planetary Resources. They were founded in 2009 and backed by billionaires including Larry Page and Eric Schmidt from Google. Their plan was ambitious: send small satellites to identify valuable asteroids, then send mining spacecraft to extract materials. They even launched a few test satellites. But in 2018, the company ran out of money and was sold. They were too early. The technology wasn't ready, and investors lost patience. Another company called Deep Space Industries had similar goals. They wanted to harvest water from asteroids to use as rocket fuel in space. Water can be split into hydrogen and oxygen, which is exactly what rockets burn. If you could refuel spacecraft in orbit using asteroid water, it would dramatically reduce the cost of space travel. You wouldn't need to launch all your fuel from Earth. Deep Space Industries also struggled financially and was acquired in 2019. But the dream didn't die. New companies have taken up the challenge. A company called Asteroid is currently working on asteroid mining technology. They've raised over $13 million in funding. Their approach is interesting. Instead of trying to bring materials back to Earth, they want to refine metals in space and only bring back the pure valuable materials. This reduces the amount of mass you need to transport, which reduces costs. They've already launched test satellites to prove their refining technology works in space. Another company, Astra, is developing technology to capture asteroids using large bags and bring them closer to Earth for mining. They call it optical mining. They use concentrated sunlight to heat asteroid material until it turns to gas. Then they capture the gas and extract the valuable elements. It sounds like science fiction, but they've tested the concept in labs and it works. China has also entered the race. They've announced plans to land on a near-Earth asteroid by 2025 and return samples. They're not calling it mining yet. They're calling it scientific research. But everyone knows what's really happening. China wants to prove they have the technology to access asteroid resources. Once they prove it's possible, commercial mining will follow. China has a history of government-funded research leading to massive commercial industries. They did it with rare earth mining on Earth. They'll try to do it with asteroids too. NASA isn't directly mining asteroids, but they're doing the research that makes it possible. The OSIRIS-REx mission successfully collected samples from an asteroid called Bennu and brought them back to Earth in 2023. This proved that touching an asteroid and taking material from it is possible. The mission cost about $1 billion, but it wasn't about profit. It was about learning. Every piece of data from that mission helps companies understand how to mine asteroids commercially. Japan's space agency JAXA has also collected samples from asteroids. Their Hayabusa missions visited asteroids and brought back tiny amounts of material. Again, these are scientific missions, but they're proving the technology works. And once technology is proven, entrepreneurs and investors start paying attention. Here's what's going to happen. Within the next 10 to 20 years, someone will successfully mine an asteroid and bring back valuable materials. It might be a company, it might be a government, but it will happen. And when it does, everything changes. The first successful asteroid mining operation will trigger a space gold rush. Unlike anything in human history, think about historical gold rushes. The California gold rush in 1849 brought 300,000 people to California. It created massive wealth. Some people got rich, most didn't, but it transformed California from a backwater territory into an economic powerhouse. The Klondike Gold Rush in Canada had similar effects. These rushes created infrastructure, spawned industries, and made fortunes. The asteroid mining rush will be bigger, much bigger, because the potential wealth is so much greater. We're not talking about finding gold nuggets in a river. We're talking about entire mountains of precious metals floating in space. The scale is incomprehensible. But here's the thing about gold rushes. The people who get richest aren't always the miners. In the California Gold Rush, the people who made the most money were selling supplies to miners. Levi Strauss got rich selling jeans. Samuel Branham became California's first millionaire by selling mining equipment. The same pattern will play out with asteroids. Yes, the companies that successfully mine asteroids will make enormous money, but the companies that build the infrastructure, provide the technology, and supply the equipment will also get incredibly wealthy. SpaceX could become one of these infrastructure providers. Every asteroid mining mission will need rockets to get to space. If SpaceX controls the cheapest and most reliable rockets, every mining company will have to use them. That gives SpaceX enormous power and profit. It's like owning the only railroad. During a gold rush, everyone needs what you're selling. The same goes for companies developing space habitats, life support systems, and zero-gravity manufacturing. All of these technologies will be necessary for large-scale asteroid mining. Whoever owns the best technology will get rich even if they never mine a single asteroid themselves. Now let's talk about the economic implications of successful asteroid mining. This is where things get wild. If someone brings back 100 tons of platinum from an asteroid, what happens to the price of platinum? Basic economics says that increasing supply lowers prices. If platinum suddenly becomes abundant, its price will crash. This seems like a problem for asteroid miners. Why spend billions mining platinum if bringing it back to Earth crashes the price? But here's what most people miss. The value isn't in selling platinum at current prices. The value is in having a massive supply of a critical resource. Yes, the price might drop, but demand will also explode. Right now, platinum is so expensive that many potential uses aren't economically viable. If platinum became 10 times cheaper, we'd use it in ways we can't currently afford. New technologies would become possible. New industries would emerge. Think about aluminum in the 1800s. Aluminum was more valuable than gold. It was incredibly difficult to extract from ore. Napoleon III served food to his most honored guests on aluminum plates, while everyone else used gold. Then in 1886, a new extraction process was invented. Suddenly aluminum could be produced cheaply. The price crashed. But did the people making aluminum go broke? No, because cheap aluminum created enormous new industries: aircraft, cars, construction, packaging. Aluminum is now one of the most widely used materials on Earth. The people who controlled aluminum production when it became cheap made fortunes. The same thing will happen with asteroid metals. Yes, prices will drop, but the company that controls the supply will still make enormous profit because demand will skyrocket. They'll be selling billions of tons of material instead of thousands of tons. Lower price times massive volume equals huge profits. There's another economic factor people don't consider. Most asteroid mining probably won't involve bringing materials back to Earth, at least not at first. The real money is in using asteroid resources in space. Remember that it costs thousands of dollars per kilogram to launch things from Earth into orbit. But if you can mine materials in space, you don't have to pay launch costs. You could build things in orbit using space-source materials. This is enormously valuable. Let's say you want to build a space station. Launching all the materials from Earth would cost billions just in launch costs. But if you could mine metal from an asteroid and manufacture station components in space, you'd save massive amounts of money. The materials might be the same, but you've eliminated the most expensive part of the equation, which is getting those materials off Earth. The same logic applies to building spacecraft, satellites, fuel depots, and even lunar bases. Everything we want to do in space requires materials. Getting those materials from Earth is expensive. Getting them from asteroids is potentially much cheaper. This creates an entirely new economy. And in space economy where materials are sourced, refined, and manufactured without ever going to Earth, this is where the real trillionaire will come from. Not from selling platinum to jewelers on Earth, but from controlling the supply chain for the entire in-space economy. Imagine being the only company that can supply metal to build satellites. Every satellite company in the world has to buy from you. Or imagine controlling the water supply in space. Because water is rocket fuel. Every spacecraft needs to refuel, and they all need to buy from you. That's monopoly level power. This brings us to a critical question. Who owns asteroids? If a company goes to an asteroid and mines it, do they own the materials? What if another company wants to mine the same asteroid? What if a government claims ownership? Space law is complicated and largely untested. The main international agreement governing space is the Outer Space Treaty of 1967. It was created during the Cold War to prevent countries from claiming territory in space. The treaty says that space, including the moon and other celestial bodies, belongs to all humanity. No country can claim sovereignty over space territory. Sounds straightforward, right? But there's a problem. The treaty doesn't clearly address whether companies or individuals can own resources they extract from space. In 2015, the United States passed the Space Act, which explicitly allows American companies and citizens to own resources they extract from asteroids. The law says you can't own the asteroid itself, but you can own whatever you mine from it. It's like fishing. You don't own the ocean, but you own the fish you catch. Several other countries, including Luxembourg, the United Arab Emirates, and Japan have passed similar laws, but not everyone agrees with this interpretation. Some countries argue that space resources should be shared by all humanity. They say allowing private ownership of asteroid materials violates the spirit of the Outer Space Treaty. This disagreement could lead to serious international disputes. Imagine if a Chinese company and an American company both try to mine the same asteroid. Who has priority? What if they both claim ownership of the materials? There's no space police to settle the dispute, no international court with clear jurisdiction. This legal uncertainty is actually a massive risk for asteroid mining companies. You might spend billions developing technology and sending a mission to an asteroid, only to have another country or company challenge your claim. Without clear international laws, there's no guarantee you'll be able to keep what you mine. This is one reason some investors are hesitant to fund asteroid mining. The legal framework isn't solid yet. But here's the reality. Laws follow economics, not the other way around. Once someone successfully mines an asteroid and demonstrates that it's profitable, laws will be created to govern the industry. It's happened throughout history. When new technologies or industries emerge, the law adapts. Radio, aviation, the internet, all of these created legal questions that didn't exist before. Governments figured it out. The same will happen with space mining. The country or companies that get there first will have enormous influence over how those laws are written. If an American company mines the first asteroid, you can bet the United States will push hard for international laws that protect their interests. If China gets there first, they'll push for laws favorable to them. This is part of why asteroid mining is not just about business. It's about geopolitical power. Control of strategic resources has always been a source of global power. The British Empire was built partly on controlling trade routes and resources. The United States became a superpower partly because of its vast natural resources. The country or companies that control asteroid resources will have similar advantages. They'll have leverage over other nations. They'll have economic power that translates to political power. This is why governments are quietly investing in space mining research even when they claim it as just science. China, the United States, Japan, India, and the European Space Agency are all developing the technology needed for asteroid mining. They're not doing it purely for commercial reasons. They're doing it because they understand the strategic implications. Now let's get specific about which asteroids are most likely to be mined first. Remember, there are over 30,000 known near-Earth asteroids, but only a small fraction of them are good mining targets. Scientists evaluate asteroids based on several factors. How close does it come to Earth? What is its orbit? How big is it? And most importantly, what is it made of? One of the most promising asteroids is called 2011 UW158. This asteroid passed relatively close to Earth in 2015. It has estimated to contain over $5 trillion worth of platinum. That's not a typo. 5 trillion in one rock. The asteroid is only about 500 meters across, but it's incredibly dense and metal-rich. If a company could successfully mine even 1% of its platinum, they'd have $50 billion worth of material. Another target is the asteroid Ryugu, which Japan's Hayabusa mission visited. While Ryugu isn't as metal-rich as some asteroids, it contains water and organic compounds. Water is incredibly valuable in space. As I mentioned earlier, water can be converted into rocket fuel. An asteroid made of ice is essentially a flying gas station. Companies are very interested in asteroids like Ryugu because water mining might be easier and more immediately profitable than metal mining. Then there's 1986 DA, an asteroid that will pass close to Earth in the year 2027. Scientists believe it contains metals worth over $11 trillion. It's been identified as one of the best near-term mining targets because of its orbit and composition. Multiple companies are already planning missions to study it. And of course, there's the big one, 16 Psyche. This asteroid is absolutely massive. It's about 200 kilometers in diameter. That's the size of Massachusetts. And it's believed to be almost entirely metal. It might actually be the exposed core of a planet that got destroyed billions of years ago. The value of metals in Psyche is estimated at $10,000 quadrillion. But there's a problem. Psyche is far away. It's in the main asteroid belt between Mars and Jupiter. Getting there takes years and requires much more advanced technology than reaching near-Earth asteroids. NASA is actually sending a probe to Psyche in 2024, arriving in 2029. But that's just to study it. Mining Psyche is probably decades away. For the first wave of asteroid mining, companies will focus on smaller near-Earth asteroids. These are easier to reach and require less fuel. The missions will be test runs, proving the technology works and establishing the economic model. Early missions probably won't be profitable. They'll lose money, but they'll generate invaluable data and experience. Just like the first oil wells, the first assembly lines, and the first computer companies weren't immediately profitable, but they laid the foundation for massive industries. Here's my prediction for how this unfolds. Within the next 5 years, a company will send a mining demonstration mission to a near-Earth asteroid. They'll extract a small amount of material and possibly bring it back to Earth, or process it in space. This mission will cost hundreds of millions of dollars and won't make money, but it will prove the concept works. Stock markets will go crazy. Investors will pour billions into space mining companies. Within 10 years, we'll see the first commercial asteroid mining operation. A company will extract significant amounts of water or metal from an asteroid and use it in space, or bring some back to Earth. This mission will probably break even or make a small profit. More importantly, it will demonstrate that asteroid mining is economically viable. Within 20 years, asteroid mining will be a major industry. Multiple companies will be operating in space. Hundreds or thousands of tons of material will be mined annually. An entire supply chain will exist. Launch providers, mining companies, refining facilities, and manufacturing plants, all working in space, and somewhere in that timeline, probably in the next 15 to 25 years, someone will become the world's first trillionaire. It might be Elon Musk if SpaceX successfully dominates space launch and branches into mining. It might be Jeff Bezos if Blue Origin succeeds with their vision of space manufacturing. It might be a person we've never heard of who is currently working in their garage on mining technology. But someone will crack the code. Someone will figure out how to mine asteroids profitably at scale. And when they do, they'll accumulate wealth beyond anything we've seen before. To put $1 trillion in perspective, Jeff Bezos, the richest person in the world, has a net worth of around $100 billion. That's a lot of money. But it's only 1/5 of $1 trillion. A trillionaire would be 5 times richer than the richest person alive today. They could buy Apple, Amazon, and Microsoft and still have money left over. That level of wealth would give them enormous power to influence governments, shape global policy, and basically do whatever they want. Some people worry about this concentration of wealth. They argue that one person having $1 trillion is dangerous. They might be right. Throughout history, extreme concentration of wealth has led to problems, corruption, inequality, and social instability. But here's the thing. Asteroid mining won't just create one trillionaire. It will create an entire new economy. Yes, a few people will become unimaginably wealthy, but the industry will also create millions of jobs: engineers, technicians, spacecraft crews, refinery workers, and all the supporting industries. The space economy could become as large as the global tech industry. Right now, the space industry is worth around $400 billion per year. That includes satellites, launches, and related services. But if asteroid mining succeeds, the space economy could grow to multiple trillions of dollars. It would rival the oil and gas industry in size. That kind of growth creates enormous opportunities for everyone, not just the trillionaires. There's also the potential for asteroid mining to solve resource shortages on Earth. Many of the metals we need for modern technology are running low. Some estimates suggest we'll run out of easily accessible platinum, gold, and rare earth elements within 50 to 100 years at current consumption rates. Asteroid mining could provide a virtually unlimited supply of these materials. This would allow technology to continue advancing without resource constraints. Imagine a world where batteries are dirt cheap because lithium and cobalt are abundant, where electric vehicles cost less than gas cars because materials are plentiful, where we can build massive solar panel arrays because silver and rare earth elements aren't scarce. Asteroid mining could enable all of this. It's not just about making a few people rich. It's about unlocking resources that improve life for everyone. But let's be realistic. There are enormous challenges still to overcome. We've talked about the technical challenges of getting to asteroids and mining them. But there are other problems too. The human factor. For example, mining asteroids will probably require people living and working in space for extended periods. We don't fully understand the long-term health effects of space living, radiation exposure, bone density loss, muscle atrophy, psychological stress. These are all real problems that need solutions. Then there's the risk of accidents. Space is incredibly dangerous. A small equipment failure or navigation error could be catastrophic. We've seen what happens when space missions go wrong. The Challenger disaster, the Columbia disaster. These tragedies remind us that space travel is risky. Asteroid mining will be even more dangerous because operations will be farther from Earth and involve complex, untested procedures. There's also the question of environmental impact, not on Earth, but in space. What happens if asteroid mining creates debris fields that interfere with satellites? What if mining operations contaminate asteroids that scientists want to study? Some people argue we should have environmental protections for space, just like we do on Earth. Others say space is infinite and we shouldn't worry about it. This debate will become more important as mining operations begin, and we can't ignore the military implications. If a company or country develops the ability to move asteroids, they have a potential weapon. An asteroid deliberately crashed into Earth would be devastating. This sounds like a movie plot, but it's a real concern. The technology to mine asteroids is very similar to the technology needed to redirect them. International agreements will need to address this risk. Despite all these challenges, I believe asteroid mining will happen. The economic incentives are too strong. The technology is rapidly improving, and human history shows that we've always pushed into new frontiers when there is money to be made. Asteroid mining is the next frontier. It's dangerous, expensive, and difficult. But so was sailing across oceans, drilling for oil, or building the internet. People did those things anyway, because the rewards were worth the risks. The race to mine asteroids is the most important economic competition of the 21st century. Whoever wins won't just become wealthy beyond imagination. They'll control resources critical to modern technology. They'll have the power to shape the future of humanity in space. They'll be remembered in history books alongside explorers like Columbus, industrialists like Rockefeller, and tech pioneers like Steve Jobs. But the impact will be even greater because asteroid mining doesn't just create a new product or industry. It opens access to the entire solar system. The first successful asteroid mining operation is the gateway to everything that comes after it: space stations, lunar colonies, Mars settlements, interplanetary commerce. All of it depends on figuring out how to access space resources. Right now, multiple companies and governments are racing to be first. They're investing billions in technology development, they're training crews, they're identifying targets, and within the next 10 to 20 years, someone will succeed. They'll bring back materials from an asteroid or establish the first space-based refinery. When that happens, the world changes, a new economy emerges, and someone, somewhere, becomes the first trillionaire in human history. That person might be watching this video right now. The next video shows what happens when that trillionaire gets the powerful.